This lesson is on sequence of transformations. In this lesson, basically we're working to create sequence of transformations, and we also need to be able to recognize them. The directions for the first problem say complete the sequence of transformations. So in number 1, we're first supposed to rotate 180 degrees about the origin, and then we are to reflect. So let's go ahead and start by taking O, which is at negative 1, 2, 3, 4, so negative 4, 3, and let's take P. P is at negative 1, and then it's 1, 2, 3, 4, 5, 6. All right, so if we're going to rotate it 180 degrees, what you're going to do is you're going to take both the opposite of the x and the y. So that would make this 4, negative 3. So that's O prime. And then P prime here would be taking the opposite of both of those, 1, negative 6. But we still need to reflect it over the y-axis. So if we're doing O prime prime and P prime prime, y-axis, y stays the same. So this y stays the same, and that means that this x has to go opposite. This y stays the same, but that means that this x has to go opposite. So now we're ready to plot these points. So we're going to do negative 4, negative 3, and we're going to do negative 1, negative 6. I believe that's 6, 1, 2, 3, 4, 5, 6. Good. And so this we're going to call as O prime prime, and this we're going to call as P prime prime. And when we connect it, there's what we've got. Using a straight edge would have been a little bit better. All right, number 2. On number 2, it says we're going to translate this down 4 units and 3 units to the right. So let's try this one just doing it on the graph. If I translate this down 4 units, 1, 2, 3, 4, and then 3 units right, that's 1, 2, 3. There's where my O currently is. And then we're going to take this one down 4, 1, 2, 3, 4, and then over 3, 1, 2, 3. So there's where that one's currently at. So currently my O is at this negative 1, negative 1, and P is currently at 2, 2. We're going to dilate it. It says to use the 0, 0 as the center of dilation, and we're using a scale factor of 2. So now to get our O prime prime, we're going to multiply this by 2, so negative 2, negative 2. And to get our P prime prime, we're going to get 4, 4. So let's plot those points. So here's negative 2, negative 2, and we can call that O prime prime. P is at positive 4, which is P prime prime. And now we can just connect our dots there, and there's our final image. In number 3, it says identify the sequence of transformations using this rule. So we can see here, there should actually be 2 primes there, sorry about that. We can see here that this is going to take 2 primes. In other words, if I'd remembered to have written it in, that means there would have been 2 transformations here. Usually you want to look at the number of primes just to give you an idea of how many transformations have occurred. Let's look at this. We know that anytime we add or subtract something to a letter, it's going to be a translation. So a translation has definitely occurred. But what I also see is that this letter right here, this y value, has gone opposite. And so we remember when we go opposite that there's probably a reflection involved or a rotation. Since both x and y didn't switch and only one of them went opposite, that means it's got to be a reflection. So let's start with that first. Maybe for the reflection, we could say this reflected, and then let's look. If this would have technically stayed the same, so if I was looking at just A prime and I left x the same and the y went opposite, x-axis, x stays the same and the y went opposite, this would be reflected over the x-axis. Then after that, to get this minus 3, we would be going left 3 units. The question is that could we have gone the other way? Could I have made that work if I had started by going left 3 units? Well, let's try that. If I go left 3 units, then that would be, in theory, A prime would actually be x minus 3, comma y. So not this one anymore, we're working with this one. And so then I say if I want to reflect it over the x-axis, this x, this whole thing would stay the same, but the y would go opposite in value, which would actually match that. So another option could be that we went left 3 units and then we reflected over the x-axis. So either one of these would have worked in this case. On number 4, it says identify the sequence of transformations. This time you've been given a set of points here, and if you'll look, we're starting with 3, 4. And so when you look over here, you can see not only did they switch places, the x and y, but only one of them went opposite. So let's think about this. 90 degrees, find the opposite of y, and switch them, which is exactly what we have. So first off, we have a rotation of 90 degrees counterclockwise. Then let's look at what happened from here to here. Well, what I see from here to here is that the value -4 stayed the same and 3 stayed the same, but these just flipped. When we had a flip like that, that's a reflection over y equals x when x and y trade places. So there's your sequence of transformations.